So good evening, everyone, and welcome to this lecture. We are into lecture 2 on electrostatics. And in the previous class, we had seen some question on electrostatics, and I think we were doing this question. Did you get the answer for this one? Equal charges are placed on the four corners ABCD of a square of length A. What is the magnitude of the magnitude of the force on charge B? Anyone got this answer? Anyone among you got this answer? Tell me first. Anyone got the answer for this one? Do it. Remember, these are the type of questions that are more likely to come and probably you'll have to solve them. So do them fast. You must have done question of this type, yes or no? Shall I do it? Square of length A. Everything is given. Yes, which answer is correct, bacha? A, B, C, D. Which one?
C.
C. C is correct.
But in place of 1, we got 2, sir. 2 root 2.
I am not able to hear properly what you are what you have said. Anyways, force applied by this and this would be same, yes or no? Because the distances are same. So force applied by this one will go like this, and the force applied by this one would go like this. We understand this, yes or no? This would be F and F. Both would be F and F. F and F. Now, there are different ways of doing this. You have to look for the shortest way. Why I'm saying the shortest way? Because you have to get the answer quickly. Now, this F and F, both F are at 90 degrees. So the resultant of this F and F would go like this at an angle of 45, which will be equal to F root 2. Yes or no?
Yes, sir.
F root 2. Now, the force applied by this charge, the pink force, the pink charge will also be in this direction. Yes or no?
Yes, sir.
The net force will be F root 2 plus F dash. This F dash is the force applied by the pink charge, and this F is the force applied by the green charges. We can just write the value of the force F. What will be the value of wrong color? What will be the value of this force F? How much is this force F? The green force. It will be K Q square by A square. Yes or no?
Yes, sir.
What will be the value of this F dash, which this other charge on the other end is applying? It will be K Q square by root 2A ka whole square. Root 2A ka whole square becomes 2A square. Yes or no? You multiply the green force by root 2 and add the other force. You will end up with your answer. Everyone understands this? Yes or no? Huh?
Yes, sir.
Okay. Remember, these type of questions are most likely to come, and that is why we are doing it. You may take them as revision or whatever you feel like. We are revising, we are doing this thing, whatever. These are the type of questions that are going to come in your exam. Next one. Shall we move on to the next one? Huh?
Yes, sir.
This is the next one. You will not get the time to solve it in the examination hall. You do it now and you remember the result. Two equal charges are separated by a distance of d. A third charge is placed on the perpendicular bisector at some distance. The force experienced by the charge would be maximum. Where should I place the charge on the perpendicular bisector so that the force experienced by the charge is maximum? Now remember, this question is simple, but you will not get the time to solve this question in the examination hall because it requires some mathematics. How will you do this? Anyone has any idea? Where will the force be maximum? There is one more question which is based on a ring. Where is the electric field of the ring maximum? The same question is this. This is a similar question. Yes. How are you supposed to do this? Remember, I don't want to waste any time. So basically, what this question is asking, just see and just remember the result. So this is just simple mathematics and nothing else. This is charge Q. This is charge Q. They are separated by a distance of d. The distance
Option
between
B, sir.
option.
B.
No, that is not correct. The distance between them is d. So this is d by 2 and this is d by 2. Where should I place a third charge so that the force experienced by this charge is 0? So let me place a charge Q here. Now, how do I find the force on this charge? I will find the force because of this. I will find the force because of this. If I call this angle as theta, this angle will also be theta. The net force will become 2F cos theta. Yes or no, bacha? And it will be in the vertical direction. Yes or no? One force will go like this. One force will go like this. Both the forces are equal. Do we understand this? Yes or no?
Yes, sir.
You just have to find out the value of cos theta. D by 2 is fixed. The only thing which is variable is this distance x, the distance of the charge q from the point, if I call this as O. So you will have to differentiate it, equate it to 0, and then you will get the force as maximum. Do we understand this? Do we
Yes,
understand
sir.
it? Don't have to do that much. You just have to remember that the result is d by 2 root 2. Don't have that much time because even if you go about calculating this, if you make a simple mistake in calculations, you will end up with an absolutely wrong answer. Remember, it is d by 2 root 2. Some things need to be remembered. Okay. So write this question, put a star mark on it. Remember this. If you're lucky, you might get the same question in the examination hall.
Completed, sir.
Shall we move on to the next one?
Yes, sir.
This is the next one, and this question has come in various forms in different exams. 5-point charges of equal value plus q are kept on the 5 vertices of a regular hexagon. It could be a regular hexagon, it could be heptagon, it could be a square, it could be triangle, pentagon, whatever. So what they do, they will put charges everywhere, but they will not put charge on one of the sides or one of the vertices. What is the magnitude of the force on the point charge minus q placed at the center?
Option B, sir.
Yes, this is very simple. So you must remember these questions. This is very simple. Option B. How did you get option B? Thank God that I am doing the revision and I am not listen to what you were saying. Sir, please move ahead. Thank God for that. That I don't trust what you say and I just go by my instincts. Okay, so this is the diagram. Normally the diagram is not given. I'm giving you the diagram as well. So this is the condition. You have to find the force on the minus q charge. Yes. And what is the answer, bacha? They could ask you force on charge. They could also ask you the value of electric field because both the questions are exactly similar. Yes, what is the answer? Huh? No one knows the answer. And you were telling me that this topic has been done 2 times, right? Now it is being done for the 3rd time. And I don't think we'll get time to do it for the 4th time. Yes, what is the answer? Why is everyone very keen to write the question? Don't be so keen to write the question. Find out the answer first. Forget about writing the question later on. You are wasting the entire time of solving the question into writing the question, which is of no use at all. Don't waste your time in writing the question. Better waste your time. I mean, spend your time, not waste your time in trying to answer it, not writing the question. I have sent almost all questions to you that you must do. The questions are there for you. You may not know, you may not write the question. You don't have to write the exact language of the question. Just draw the diagram. This is the question. You have to find the force on the central charge. What is the answer?
Option A.
Option A. Should not have taken so long. Option A. Why? This charge will cancel out this charge, whether you call it electric field or whether you call it electric force. This charge will cancel out this charge. The net force will be because of this charge only, the green one. It will be attractive in this case. And the answer is force due to one charge. It is a regular hexagon. Length of everything is L. So answer is KQ square by L square. Do we understand this? Huh?
Yes, sir.
We must understand this. Okay, there is no 5th time that we can come here. Okay, there's no 5th time now. Okay, remember my entire intention is to do all types of questions that are possible to come. This one also, I think this is from your module. And if it's from your module, probably you would have done this. But anyways. This one. 3 equal point charges of charge plus q are moving along the circle of radius r with a minus 2q charge placed at the center. The charges are moving with uniform speed, same speed. Find the speed of the charges. The diagram is not given in the question, but since we don't have time and you have done it 2 times, I'll give you a diagram because I can't give you so much time that I give you time to think and then I give you the diagram. As you can see, time is a luxury that we don't have. So I'll give you a diagram so that with this diagram, you should be able to solve the question quicker. Quicker was one of those websites where you used to buy and sell stuff. Quicker. It's now gone. But You have to do it quicker. Now it is quicker cars. No one buys and sells. Yes, this is how the diagram is like. To find the speed, I think we have done a similar question, but that time it was only one charge at the center and one charge evolving. Now it is three. They can make a question with four. They can make a question with five. They can make a question with hexagon also. Doesn't matter. The concept remains same. Yes, you have 2 minutes to do this. These are the type of questions that are more likely to come from electrostatics. Apart from whatever question I think that will come, shall come. 2 minutes you have. Make the best use of the time that you have, bacha. I'll also try to present to you some questions on the previous year papers. So I've prepared everything. It seems like I am putting a lot of effort and you are not. But my effort should not go in vain, because when my efforts go in vain, I get very angry. What will I do? You're not here. I'm not there. I can't even give you a tight slap. So what? Do it. Fatafat. I like your smiling faces and I want to keep them smiling always. Oops, what has happened? The question got upar niche. Now it got right. I was trying to get to that thing. Huh? Where is electrostatics? Electrostatics. It's electrostatics. Electrostatics. Yes, my dear friends. See, everyone is looking here. We have done this 2 times, na sir? Sir, please don't do it. We have done it 2 times. And if the say if a question comes from here, sir, we have done it 2 times, but it is useless. Remember, with time we tend to forget things. So take it as a revision that we are revising, because that is the only thing that is left for us to do now. Do it fast. No one knows the answer. Chalo, shall I do it now? I think I give you enough time. You just take any of the charges that you feel good about. Let me take this charge. Oh, let me take this charge. This charge looks good. Let me take this charge. Now let us see what are you can't see this. Let me see what are the forces this charge experience. One is this force, attractive force F, because of the minus Q charge. Yes or no? Huh?
Sir, root over 2m k q square by r cos theta by 2.
What is cos theta? Okay. Anyways, you have tried, that is good. One is force F here because of the central charge. Then there comes this force from this green charge and this force from this green charge, and both these forces, let us call them F dash and F dash together. Yes or no? No or yes? Do we understand this, or this has gone above our head saying bye bye? I'm going. So what will be the net force? Now you can find this net force in a variety of ways. We have done this question before. Equilateral triangle, you found out the net force. The only thing is here is there is one more force coming in the downward direction. What is the centripetal force? The centripetal force experienced by this will be F minus 2 times F cos of 30.
Sir.
Yes or no? Do you remember that question that we did? Equilateral triangle. Huh?
Yes, sir.
That's it. That is your answer. You just put the value of F and that will be equal to mv square by r. Bacha,
Sir, answer is under root KQ square by R.
no, the answer is this. Under root KQ square by 2m 2 minus 1 by root 3. That is the answer. See, we do each and every question for some reason. The problem is you are not concerned now. This equilateral triangle we had done before, see? And that time you were not concerned. Sir, I know the answer. See, this question. If you would have done this question carefully enough, you would have known what is the net force on this charge because of these two charge placed here. Yes or no? You just had to find out one more force and that is equal to mv square by r. So I do everything for a purpose, beta. If you don't understand that purpose, well, what do I do? The only thing different here is you have to calculate the distances here. The distances are also different. This distance is r. This is r. You have to find out this distance. This is pure maths. How much will be this distance? How much will be this distance? Anyone?
Root 3R, sir.
Thank God. God exists. Root 3r, sir. That is correct, sir. So you just put that value root 3r. If you were to remember that result, you could have put that result and get your answer. Remember, JEE is not going to test your ability to solve the problem. It is going to test how quickly you can do a problem. If you cannot do the problem quickly enough, you are done. Because then you would be wasting your time in doing something which the other person can do it quicker than you. Okay, remember this. Do we understand this now? Yes or no?
Yes, sir.
Okay, then again I will take you to one more question, which is a favorite question. It is given in almost every book that you open. This one. Now before going to this question, let me give you this. Let me give you something that you can work on, and then probably things would become simpler for you. So write the heading: equilibrium of suspended charge system. So we can do it as a equilibrium of suspended charges, because this question can come in JEE as well as IIT, JEE Advanced as well as JEE Main. So you can just take the theory behind it. So this is how the question is there. You have 2 point charges. They hang them from a string. The string is hung to the what ceiling, and then they give it charge. They do, and then pudung happens. Then they ask you what is the value of x. Do you know this question, na? Yes or no? Huh? They ask you what is the value of theta and this and that and ping and pang. So this is the free body diagram of this thing. The two charges are equal. So there are three forces that are acting on any one of the charge that you see. Do you see these three forces? One is this Coulomb's force of attraction, repulsion, Coulomb's force, electrostatic force. One is this our friendly Spider-Man tension. And the next one is your weight mg. Do we understand this? And this system will remain in equilibrium. Draw this diagram. Everyone knows how to draw this diagram, yes or no?
Yes, sir.
What are the equations of this diagram? Fatapat, tell me. Huh? So one equation is T sine theta will be equal to the electrostatic force, yes or no?
P.
And your T cos theta will be equal to mg, yes or
MG.
no? Yeah, so you can straight away write our friendly Spider-Man tan theta will be equal to Fe by
P
mg.
by MG.
Remember these simple things. Remember these simple things. Okay? Tan theta is this. Now, sometimes they might give you this theta is small. So just take everything as a note. If theta is small, then what happens, my dear friends? This theta, tan theta,
F
sin
equal to
theta,
MG.
all are equal, right? Yes or no? Yes or no, bacha?
Yes, sir.
Okay. Then you can write this sin theta or this theta or tan theta is equal to x by 2l. X by 2 divided by L, yes or no?
Yes, sir.
And that will be equal to your electrostatic force. Electrostatic force is your K Q square by R square. R square in and R is your X. R is your X. X square mg. So from here you can find out the value of X. The value of X would be equal to 2kq square by mg ka cube root, where k is 1 by 4 pi epsilon naught. Do we understand this? Huh?
Yes, sir.
Okay, now they can give you a special case here. They may give you a special case if this entire arrangement is taken in an artificial satellite. I've seen a case like this. If this entire is taken in a space of an artificial satellite, basically what they mean by artificial satellite is your G becomes equal to 0. Do we understand this? Huh?
Yes, sir.
Then how will the arrangement look like? If you take it to a place where G is not there, how will the arrangement look like? How does the arrangement look like if you take it? And what will be the tension in the string in that case? If you take it to a place where there is no G, take it to a satellite where G is not there, how does the arrangement look like? Remember these small things, because in the examination hall you might not get sufficient time to think about them. The arrangement, since G is not there, there is nothing to pull it down, so they come like this. Do we understand this? There's nothing to pull them down. There's no G, so they will get repelled and they will stay in this position. We understand this?
Yes, sir.
So in that case, your tension T would be equal to the electrostatic repulsive force, and that will be equal to your K Q square by the distance between them will become 2L, so 4L square. Do we understand this, or this has gone above our head saying bye bye, I'm going, don't worry about me? Huh?
Understood, sir.
Now this is a very famous question. It has been asked many times here and there. You'll also always find in a lot of books, a lot of question ask this, a lot of students ask this question as a doubt. So I'm sure you're going to ask this as a doubt. So let us solve this as a doubt as a question. So the question goes like this. I've told you the entire theory behind it. I have nothing else to tell you. So now you should be able to solve this question and get me the answer. Two identical charged spheres are suspended by strings of equal length. The strings make an angle of 30 degrees with each other. With each other. Remember, with each other. When suspended in a liquid of density 0.6 something something, the angles remain same. What is the dielectric constant of the liquid? Density of the sphere is given as 1.6 gram per cc. Huh? Any idea? No idea. Get idea. You have 2 minutes to give your ideas. I've told you everything that you need to know. Everything. Everything. Now you have to apply your common sense, which I know all of you have. You just don't apply it. Have you done this question before, bacha? Huh?
True, sir.
कोई बात नहीं. Try it. It's not necessary that you would have done everything.
Answer 2, sir.
Okay, you're giving me the answer. Well done. How did you get it? I think answer is 2. Answer is 2. How did you do it?
Where becomes to B by B minus C.
Sorry, beta, I was not able to understand what you said. Can you repeat it? Can you repeat it, please?
K dash equals to rho by rho minus D. Density of the
Okay, I'm trying to I'm trying to understand what you're saying. How did you get that? You remember the formula, right?
by tan equals to F by V minus rho into G, sir. From that we can divide both equations. We will get K dash equals to D by D minus E.
Okay, I think you are telling me the correct. I think that is correct. Whatever I can make it of. See, I've told you everything as I said. Everyone has done this. Now, if you just remember what was said, I gave you the value of tan theta beforehand, right? Now, the value of tan theta was electrostatic force divided by the weight mg. Tan theta, that was half of the angle. It is not tan of 30, it is tan of 15. We understand this, tan of 15? Now, in first case, angles remain same. So, in first case, this tan theta is equal to the force in vacuum divided by mass into g. Now, this must be equal to the force in the liquid, force in the medium, divided by the weight in the medium. So, m into, I can write it as g dash. Mass remains same, the g becomes different. Yes or no? Because of the buoyant force. Everyone understand buoyant force?
Yes, sir.
We just put the values now and I will get the answer. F divided by m into g should be equal to this f dash would be your F divided by the dielectric constant K. Yes or no?
Yes, sir.
Mass remains same. The G becomes effective G and you can write it as 1 minus your density of what divided by what? Density of liquid, which is 0.6 0.8 divided by the density of the sphere. Do we understand this?
Yes, sir.
If you don't understand this, you can have a look at this diagram, bacha. See, this is the sphere. In air, the weight is mg. There is no buoyant force. When it is dipped inside the liquid, the weight is still mg, but then we have a buoyant force Fb. So its weight becomes apparent weight. That becomes mg minus Fb. And this Fb is volume of the entire solid into density of liquid into G. Do we understand this? So in the second case, whatever weight we are using is this effective weight. Do we understand this, bacha? This is this effective weight that we are using. We understand this? If you don't understand this, I will try to solve this again. So this is mg minus volume of the solid into density of liquid into G. Right? Now, you can write this in terms of the actual mass. So I can take m into G common, m into G common, and I can write it as 1 minus density of liquid divided by the density of solid. So you can remember this as your shortcut. Okay, I've just taken density of the solid outside the bracket and I've divided by inside. So that is what you need to do. You now can equate things on this side. F and F goes away, M and Mg goes away, and you will get your answer. K will come as 1 divided by 1.6 minus 0.8 divided by 0.6. It goes up. K will come same as 2. The value of K from here will come as 2. What you got to remember is this formula for apparent weight. Remember it. You might need it in some other question on buoyancy as well. So with this question, we covered your buoyancy as well as we covered your electrostatics as well. Anyone has noted this down?
Yes, sir.
See, now let me give you a question from anyone understood this? See, the type of question that come in your JEE Main is way simpler. This is the question from previous year. See this? These are the type of questions that are going to come. Trust me. I mean, from the part that we have covered, not talking about the part that we have not covered. There are other questions as well, but we have not covered those parts. See? Give me the answer for this one. I think you can easily manage it. Three charges plus q, small q, and plus q are placed respectively at a distance of 0, d by 2, and d from the origin on the x-axis. The net force experienced by plus q is 0. What is the value of q? See? Now, remember, I always keep on telling you, JEE Main is 100% a test of your speed. If you can do the question quickly enough, you would be able to score heavily. That is why you keep on practicing questions of this nature. See, I did not give any question of this nature, but you see, that is the question that is coming. That is why I don't leave anything to chance. I give you all type of questions that are possible, because you never know which question will land up in your paper. And if I just skip that question, I will not be able to forgive myself कि काश ये question करा दिया होता. Even if you can't do it after that, I am not worried. But I should be confident from my end that I had done that question. Students are not able to do it, well, that's their karma. My karma is that I should be solving all the questions that are possible.
Sir, option D.
Option D, I am looking at the answer. Let me see. I have not given the question and I was looking at some other question. Option D, let me check. I've forgotten the question also. Yes. 3 charges are placed here. And where is the question? Right? Question is gone. Where is the question? I was looking at some other question. I forgot the question. Everyone got the answer? Yes, I got the answers here. What was the question? Question number 5 was the answer is D minus q by 4. Anyone got this?
Yes, sir.
Well done. Then you get +4 in JEE of 2019. Congratulations. How are you supposed to do this? I guess everyone understands this. Yes or no? Do I need to do this or you understand this?
Understood, sir.
Understand, sir.
They are just in a line and you just have to find the net for this. Nothing. See, such simple questions come in JEE. So that's what I've given you. I've sent you that sheet. Please work on the sheet that I have sent you. I can assure you that questions are going to come from that sheet or from what I am doing in the class. The next thing that we are going to do is electric field. I should not call it electric field. I should call it electrostatic field. So even though I am writing electric field, you must write it as electrostatic field because this is chapter name is electrostatics. We are dealing with electrostatics, not with electric field. Electrostatic field or electric field. Let us use electric. What do you mean by electric field? Yes, you have done it 2 times. Tell me what is electric field. Huh? Electric field is denoted by this legendary letter E with a vector sign. Yes, what is electric field? Tell me what is electric field. No one knows it.
Around a charge, its influence felt by any other charged particle, sir.
Okay, that is fair enough definition of electric field. So electric field is any, I mean, it may not be around a charge. It can be a very large distance from the charge. Books might say around the charge, but may not be around charge. Any region in space, it's a region in space. That is how I define it. It's a region in space. It's a region in space where what? Where a charge experiences electrostatic force. Where a charge experiences electrostatic force. A charge can experience gravitational force. I cannot say whether, I definitely cannot say that there is electrostatic field there. If a charge experiences electrostatic force in any region of space, that region we say is a region which has an electric field. Now, how do we understand this electric field? We understand it by this term of electric field intensity. So this electric field is a region in space, and this E vector is actually electric field intensity or electric field strength or electric field magnitude, the strength of electric field. How do we measure the strength of electric field? How do I measure the strength of electric field at any point in space? I have to measure electric field here. How will I measure it? No one knows it.
E is equals to KQ by R square.
No, that is not how I can measure it. See, I don't see any Q here. I don't see any Q here. So where is my Q? Where is my R? How will I measure it? I don't see any Q here. So I cannot find it by KQ by R square. Yes or no, bacha? So how do I measure it? I put a small charge plus Q, small charge. It should be very small. This small charge is known as a test charge. What is this known as? This is known as a
Test charge.
test charge. I keep a small charge, a test charge, and I find out how much force that test charge is experiencing. If it is experiencing a force F, it could be in any direction. Electrostatic force I am concerned about. If this test charge is experiencing an electrostatic force F, then I can tell you the magnitude of electric field or the intensity of electric field. The intensity of electric field will be F divided by Q, the value of this test charge. But it should be very clearly or very correctly written like this: limit of this Q should be tending towards 0, F by Q, because I must keep this test charge as small as possible. Because if I keep this big charge, it may not be big. If the magnitude is big, it will create its own electric field. And if it creates its own electric field, its purpose is not to create electric field. Its purpose is to just measure the field created by someone else somewhere. So if it starts to create its own electric field, the purpose of putting the charge is gone, because then the electric field will be distorted. So I want to keep it as small as possible. This is known as a test charge. Do we understand this? Or it has gone above our heads saying bye bye, I'm going, don't worry about me. So we cannot measure it by KQ by R square. We have to measure it by the force and divide it by the test charge itself. Clear?
Yes, sir.
Next point that you will write: a positive charge will experience force in the same direction as electric field. Write it. Plus Q, positive charge will experience force in same direction as electric field E. What about negative charge? Huh? What about negative charge?
Opposite direction, sir.
It will experience force in the opposite direction. From this revolutionary equation, I can also find out the relation between electrostatic force and electrostatic field. Electrostatic force experienced by any particle in any field can be written as Q multiplied by E. So you find out the electric field at that point and multiply it by Q, you get the electrostatic force. So whatever questions we have done till now, 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 whatever questions we have done till now are also questions of electrostatic field. Do we understand this? So if
Yes,
in
sir.
this question, what the question was, just JEE wala question, if I remove the minus Q charge from here, the question will become find the electrostatic field at the central point. Do we understand this?
Yes, sir.
All the question that we have done till now, all the question that we have done till now, all the question that we have done till now, this one, if I remove this charge from here, this will not become a question of force, this will become a question of electrostatic field. Do we understand this?
Yes, sir.
All the question till now what we have done, all the question till now what we have done, all the question till now what we have done are questions of electrostatic field. If I remove the charge from here, this becomes a question of electrostatic field. Do we understand this?
Yes, sir.
Remember this. So we may not do all these questions again. These questions are already done. So we'll move ahead with more questions, different questions. Now remember the questions of electric field Electrostatic field are questions of electrostatic force, and the questions of electrostatic force are also questions of electrostatic field. Keeping that in mind, we will not be repeating these questions. We will be moving ahead with some other questions in the next class. And I hope that I can finish electrostatic field by the end of this class, so that from the next class on Saturday, we can move on to things that you have done only for the first time in your life. And whenever you do something new, you do it for the first time. So I hope that we can cover that question that I want to cover in the next class. If we can cover them, we'll move on to the next topic. Take care. Have a nice day. God bless you all. Bye bye.
Bye, sir.